Hello, so we've talked about displacement and velocity. Now we're going to talk about acceleration. What is acceleration? Well, an acceleration is any change in velocity. And there's three ways that you can change your velocity. You can speed up, you can slow down, or you can change direction. And because velocity has a direction, if you change direction or turn, that's also considered acceleration. Acceleration is the rate at which your velocity changes. So there's two components. So A, average, then the bar means average. Your average acceleration equals your change in velocity over time. And if we expand that would equal V2 minus V1 all over T. It's supposedly a 2. So V2 minus V1 over T is equal to your acceleration. So the more quickly you change your velocity, the greater your acceleration. So if you're not making a turn, then your acceleration is also equal to your change in speed over time. And this is what we're going to be doing. When we deal with this equation, we're not going to be turning. We're just going to be looking at the change in speed divided by time. Okay. So now if I take this equation, as we've already seen, I substitute V2 minus V1 for delta t. If I solve this for V2, I get V2 equals V1 plus AT. This is a useful form of the equation, and because if you're looking for V2, it's already solved for V2. So if we were to look at a car, we got two cars, blue and red, and I asked you which car had the greater, which car had the greater acceleration. It doesn't want to work for me. There we go. Which car had the greater acceleration? So which of these cars has a greater acceleration? Well, it'd be the car that came to a stop first, which would be the blue car. It had the greater change, the rate of change of velocity. So anytime you accelerate, you can feel a force. That's because forces cause accelerations. We'll deal with that next unit, or the unit after that. So when you hit the gas pedal, there's a force accelerating you forward. When you hit the brakes, there's a force accelerating you backwards. And when you turn the steering wheel in your car, there's a force that's causing you to accelerate around a turn. So keep that in mind. And you accelerate in the same direction as the force is on you. Okay, so let's work a quick problem here. We hit the gas and go from rest to 15 kilometers per hour in 3 seconds. What's my acceleration? So my V1 is 0, my V2 is 15 kilometers per hour, and my time is 3 seconds. So what's your acceleration? Well, acceleration equals V2, which is 15 kilometers per hour, minus 0 over 3. So that equals 15 kilometers per hour divided by 3 seconds. So if I look at, units aren't real clear here, and I'm going to get 5. And the unit on this is going to be kilometers per hour per second. Okay? And that's what the acceleration in this case is going to be measured in. And what that means is that my velocity changes by 5 kilometers per hour per second. Okay. So what happened is on the previous slide, we accelerated from rest to 15 kilometers per hour in 3 seconds. So after the first second, we were at 5 kilometers per hour because our velocity changes by 5 kilometers per hour per second. After another second, we were at 10 kilometers per hour per second, 10 kilometers per hour. And then after 3 seconds, we sped up to 15 kilometers per hour. So that's what the acceleration means of 5 kilometers per hour per second. Let's say we speed up from 15 meters per second to 40 meters per second in 5 seconds. What is the, well, we have our V1, we have our V2, and we have our time. So my acceleration equals V2, which is 40 meters per second, minus 15 meters per second over 5 equals 25. Is that going to be 25? 30, yeah, 20. Equals 25 meters per second divided by 5 seconds. And that's going to equal 5 meters per second per second. Now, if I simplify this, and what this means is my speed changes by 5 meters per second per second. Each second, my speed changes by 5 meters per second. I can rewrite this as 5 meters per second squared, because that's what the seconds will go together. So simplifying that, we get meters per second squared. And that's why I'm sure you've seen acceleration measured in meters per second squared. And that's what a meter per second squared means, is literally it means that 15 means meters per second each second. Okay, so now velocity and acceleration are both rates. Okay, velocity is the rate at which your position changes. Acceleration is the rate at which your velocity changes. So keep that in mind. They're both rates though. Okay, let's say we start from rest and we have an acceleration of 6 meters per second squared. How fast am I moving after 1 second? Well, I'd be moving at 6 meters per second. And then after 2 seconds, I'd be moving at 12 meters per second, and then 18 meters per second. So that's literally what 6 meters per second squared means. Okay, let's say that I was originally moving at 10 meters per second, and now my acceleration is 4 meters per second. Well, after 1 second, I'd be moving at 14, and then I'd be moving at 18, and then I'd be moving at 22. Okay, so nothing too complex here. What is the acceleration in this situation here? The acceleration would be that there's a difference of 5, a difference of 5, and a difference of 5. So 5 meters per second squared would be the acceleration. Don't forget the unit. Let's say we've got a car initially moving at 4 meters per second. It accelerates at 2 meters per second squared for 6 seconds. How much does the velocity change, and what is the final velocity? We're going to skip that first part. How much does the velocity change? Well, and we're going to look at the final velocity. Well, the change in velocity is going to be 12. If you can work that through in your head, the velocity is going to change by 2 meters per second squared per second, 2 meters per second for 6 seconds, so that'll be 12. But anyway, let's work at this. So what we're looking for is V2. Okay. And remember that form of the equation I gave you, V2 equals V1 plus AT. Okay. So V2 equals V1, which is 4 meters per second, plus A, which is 2, it's not going to let me draw it. There we go. Times 6 seconds. So I should have had the units on here. So this is a meter per second squared times a second. Meter per second squared times 6 seconds. I know that's hard to read. So now when I multiply these two together, I'm going to get 12. And meter per second squared times second, this second is going to cancel out with one of these seconds, and I'm going to get with a meter per second. And that's the unit on the 4, which is a unit per second, because that or meter per second. And that means I can add these two numbers because they both have units of meters per second. And that gives me 16 meters per second is my final answer. V2 equals 16 meters per second. So all the units worked out. Just wanted to show you that we learned what we learned last unit still applies for all the units, except that we won't worry too much about sig figs. Just be reasonable with sig figs, and we'll call it good with that. How long will it take a car to go from 25 to 55 meters per second? Sorry, if it accelerates at 5 meters per second squared. Work this one. So we've got our V1 is 25 meters per second, our V2 is 55 meters per second, and my acceleration, again, the tip off that's my acceleration, that 5 meters per second squared is my acceleration, is the unit. Always look at the units to verify what something is, and that's meters per second squared, which is correct. And I'm looking for how long, in other words, I'm looking for the time. Well, there's two forms to the equation, and I can use either form. I'll probably go ahead and use this form, V2 equals V1 plus AT. This is the same equation as A equals V2 minus V1 all over t. Oh, that's how it's going to work. I see. That's not what I was hoping. So that's the same equation. It's just solved differently for you. So we'll plug in our numbers here. So our V2 is 55. So 55 equals V1, which is 25, plus my acceleration, which is 5, times t. Okay. So what's the first thing I want to do here? I want to subtract off the 25 from both sides. So what I'm going to get is 30 equals 5t. Okay. And then divide by the 5 and we get t equals 6. And the units on that, if we had followed them, would work out to be seconds. So that is something to be mindful of, the units. Okay. Let's say we had another type of situation, and this one I'm going to let the computer work. You were moving at 60 meters per second initially, and you open up your parachute, and your car comes to a stop 5 seconds later. What's your acceleration here? Now, my V2 in this case is going to be 0. My final velocity is going to be 0 because I'm coming to a stop. My initial velocity is 60, okay? And my t is 5 seconds, so that's that. And when I do this, I'm going to get a negative 12 meters per second squared. What does the negative mean here? Okay, well, it means that I slowed down in this case because I had a positive velocity, which we'll beat that to death a little bit later. But in this case, that means that it slowed down. So because it was moving to the right, the acceleration and the force was pushing it to the left. So that's why it's to the left is negative. So that's why it means that here. So let's say you had initial velocity of 10 meters per second, and your acceleration is negative 5 meters per second squared. So after 1 second, you're going to be moving at 5 meters per second. And then after another second, you're going to be moving at 0 meters per second, or not moving at all, for that matter. And then after another second, you're going to be moving at negative 5 meters per second. So what happened here? Well, I was moving forward, and then I slowed down. I came to a stop, and then I started moving backwards. Okay, so that's what happened in this scenario. So the direction of the acceleration is the direction of the acceleration of the force applied to it. So if you want to cause something to accelerate to the left, you push it to the left. If you want to cause something to accelerate to the right, you push it in the right direction or positive direction. So here we've got a car, and is my velocity positive or negative? Well, my velocity would be positive because I'm traveling to the right. Now, if I push it to the right, okay, meaning I accelerate it to the right, okay, what's going to happen to its speed? If it's moving to the right and then there's a force acting on it to the right, it's going to speed up. Okay, so it's going to speed up if it has positive acceleration. Now, in this case, would the velocity be positive or negative here? Well, it's still traveling to the right, so the velocity is positive. Okay. Now, this time we're going to apply negative acceleration. Okay. So that means I'm going to push it to the left. It's going to accelerate to the left. So if I push it to the left, is that going to cause it to speed up or slow down? It causes it to slow down. So in this case, the signs were opposite, and it slowed down. Previously, we had positive acceleration and positive velocity. We sped up. Here we had positive velocity, negative acceleration, and it slowed down. So if the signs were opposite, it slowed down. Okay, would our velocity be positive or negative here? Well, it'd be negative because we're traveling to the left. Okay, let's say we have a positive acceleration here. What's going to happen to its speed if we have a positive acceleration, if we've got a negative velocity? Well, if it's traveling to the left and I push it to the right, it's going to slow down. Okay. So is it slowing down? Yes, it's slowing down very slowly. And so here again, the signs were opposite and it slowed down. Let's look at what happened if we have a negative velocity and a negative acceleration. Okay, well, what's going to happen if it's moving to the left and I accelerate it to the left? It's going to speed up. And here is it gonna be speeding up, and there it goes. Okay, so the takeaway from that is whenever the signs of the velocity and the acceleration are the same, the object speeds up. Okay, like positive, positive, negative, negative. If the signs are opposite, then the object slows down. So that's something I would definitely know. And we're just about done with the notes. Let's do number 9. So a car initially moving at 5.6 meters per second accelerates at negative 1.1 meters per second squared for 6 seconds. What's its final velocity? Okay, well, I'm going to go ahead and use the form of the equation v2 equals v1 plus 8. So we've got our initial velocity v1 is 5.6 meters per second. Okay, and then we've got negative 1.1 meters per second squared. Again, it tells us that we're accelerating at a rate of 1.1 meter per second squared. So that's my acceleration, because it's telling us its acceleration and the units are that of acceleration. So that is my A. And then for 6 seconds, that's my T. And we're looking for V2. So that's the reason I definitely want to use this form of the equation. V2 equals V1 plus AT. I'll give you both forms on the test. You do not have to memorize equations in this class, but you got to know how to use them and do the algebra. Okay, so V2 equals V1, which is 5.6, okay, plus A, which is negative 1.1 times T. Okay, it's not letting me put decimal places, whatever. So that means V2 equals 5.6. Very frustrating when it does this. Equals 5.6 minus 6.6. Okay, so 5.6 minus 6.6. So my answer, V2, is equal to minus 1.0. Okay, this drawing on the screen is almost worthless with this computer. Sorry about that. In my mind, this was going to work out great. I was going to be able to do all this annotation on the screen, and that's what you get. Okay, let's see this last problem. What is the acceleration of a car which is driving at a constant 320 kilometers per hour on a straight road for 10 seconds? Okay, so let's look at what we got. So we've got a car, it's moving at a constant 320. Is that my, and we're looking for the acceleration. So I'm going to use the form here. Acceleration equals delta V over T. So T is easy, that's 10 seconds. Oh, I'm not having this. T is equal to 10 seconds. What is delta V? Well, if it's moving at a constant 320 kilometers per hour, that's the initial velocity and that's the final velocity. What do I get if I subtract 320 minus 320? I get 0. So we got 0 over 10, and that equals 0. So basically, if it's moving at a constant speed in a straight line, then the acceleration is 0. Okay. All right. What I want you to do is, won't let me drop this annotation. Do worksheet 2.2 now, and well, good luck with it.